Hey everyone, this is Miss Moriarty, and I'm here to discuss with us our very first topic of Unit 4. Remember, I mentioned we're going to begin Unit 4 by talking about geology, right? The study of specifically Earth. So, in the first topic here, we're going to be talking about plate tectonics. So, Earth is actually comprised of many different plates or landforms, like ocean plates as well as land plates. Those plates can move in different directions, either spreading out or converging, coming together. Now, specifically looking at Earth's structure first, we can see the core of the Earth. That's going to be the dense mass of solid things like nickel, iron, or other radioactive elements that are going to release tremendous amounts of heat. Moving out right from the core would come the mantle or the liquid layer of the magma. This surrounds the core and is usually kept liquefied due to the intense heat. Now, followed by what's known as the asthenosphere. So, this is the solid, more kind of flexible outer layer of that mantle, and this falls right below what the lithosphere would be. The lithosphere is going to be the very thin, brittle layer of rock that kind of floats on top of that mantle. This is what's actually broken up into the tectonic plates that we talk about. So, in our Oreo plate tectonic activity, a part of the upper cookie that you were working with today was the lithosphere. Now, the crust is going to be the then very outer layer of that lithosphere, and that's going to represent actually Earth's surface. Now, a part of Unit 4 is going to be talking a lot about convection currents. This is going to be a big theme that comes up in pretty much all topics we talk about in Unit 4. Now, we saw convection, and we talked a little bit about it today in the Oreo plate tectonic activity. Now, when we talk about convection, right, we're talking about, in the case of plate tectonic activity, the very hot magma that stems from Earth's inner core is actually going to rise towards the lithosphere. That rising magma winds up cooling, condensing, and expanding, forcing other plates to then move apart. In the case of oceanic plates moving apart, this might create things like mid ocean ridges, volcanoes, or spreading zones, or termed as seafloor spreading. This magma will wind up cooling, eventually solidifying into then new lithosphere. So you can kind of see that in this little GIF here, right? So the rising magma, right, comes up, eventually it spreads apart, cools, condenses, solidifies, and it kind of continues that cycle. Now, that spreading magma winds up forcing then oceanic plates potentially into continental plates or land plates. This is where we wind up seeing what's known as a subduction zone. So, this is where two plates are going to be converging to one another. Because oceanic plates have more density, they're usually going to subduct downwards, while the continental crust typically is going to shift upwards. This is then going to take that then plate and melt it back into magma and continuing that cycle. And you can kind of see that here, right? So here would be your divergent plate boundary, right? That floor spreading versus here would be your convergent plate boundary, specifically subduction. Now, if we break down the plate boundaries into three types, we would get divergent, convergent, and then a transform fault plate boundary. Divergent plate boundaries, we know the plates are going to move away from one another, and as a result, rising magma is going to come upwards. We said this forms things like mid ocean ridges, volcanoes, seafloor spreading. A transform fault plate boundary, this is where those plates are now going to slide past one another in opposite directions. And so when we talk about earthquakes, typically stem from a transform plate boundary. Convergent plate boundaries, we said that's where two plates are going to move together. Now, depending upon what type of plates are interacting with each other, we might see subduction, we might see the formation of mountains or collision. So here's a nice little visual of our three types of plate boundaries. So our transform, we know our plates are moving in opposite directions. converging, we know our plates are coming together, versus diverging, our plates are moving away. Now, furthering to kind of break down our types of convergent boundaries and what may take place, remember, depending upon what two plates are interacting at the boundary, tells us what's going to happen and what might form. When we see two oceanic plates, we see one is going to subduct or fall underneath the other. This is going to force, right, magma up. So that's what you can kind of see right here. This potentially forms mid-ocean volcanoes. It can also form things known as island arcs. So these are going to be rows of islands that are formed due to volcanic activity. When we see an oceanic and continental plate interact, we could see the oceanic crust falls below the continental crust, and once again, it forces magma upwards. You can see that here. This can create coastal mountains. It can also create volcanoes on land, trenches, or even tsunamis. Versus now continental, or two land plates coming together. We can see one plate is going to subduct underneath the other, forcing that surface crust to move upwards, creating things like mountain ranges. Now, looking specifically at our transform plate boundary, the plates are going to slide past one another in different directions, creating fractures in the rock surface. So, when we see earthquakes, which tend to happen because of our transform plate boundaries, this is when rough edges of those plates actually get stuck on each other. So, as you were simulating that with your cookie today, you should have noticed that as you try to slide the two pieces of cookies past one another, at certain points it may have been a little bit tougher. And so, as you begin to try to slide those two halves of the cookie past one another, pressure or potential energy should have built as you did that. And once you slid the slide of the cookie past each other, you then release tremendous amounts of energy. So, when the stress kind of overcomes that locked fault, that's when you experience a release of tremendous amounts of energy, shakes the lithosphere, and that would be your earthquake. And so the last piece that we need to know in terms of plate tectonics, depending upon what plate we might be looking at, can actually form geological features on Earth. So one of those geological features that you should be familiar with is what's known as the Ring of Fire. So this is going to be the pattern of volcanoes that we tend to see all around the Pacific Plate and the offshore island arcs in Japan. So, because of the subduction that is occurring along these plate boundaries, this forms tremendous amounts of volcanoes and the formation of islands. We can see transform faults, which is where we might see earthquakes happen, or there would be more likely to be earthquakes happen here. We mentioned in class today, right, along the San Andreas Fault in California, they tend to experience a little more earthquakes than we do because they might live along that fault plate boundary. And the last one is what's known as a hotspot. So this is going to be an area of very especially hot magma that rises up towards the lithosphere, and this is where we tend to see a lot of island formation is in hotspots. All right, everyone, that is it for our video on 4.1 or plate tectonics. Make sure as you watch the video, you took notes and then leave at least one question that you still have about the topic.